Hey everybody, welcome back. What we are going to be learning in the lesson today is specifically on slope. In a previous lesson, you learned about y equals mx plus b. We're going to be talking about the m of that equation today. Just the m. We're not even going to talk about the y-intercept and how to put that together yet. What you need to be able to do is find the slope if I give you 2 points. You need to be able to find the slope if I give you a graph. And you should be able to understand what it means to have a slope be 0 or undefined by the end of this video. So first thing you have to know is this formula. So I wrote a lot of things in here. All of these mean slope. So you should have learned this in Algebra 1, but just as a little reminder, if you want to take notes, put this formula down. Slope is rise over run. That means how far up you move in comparison to how far left and right you move. That is also the m in y equals mx plus b. And the formula next to it, y2 minus y1 over x2 minus x1, that's taking the 2 points that you get on a graph and subtracting them from each other. So the y values get subtracted, the x values get subtracted. So in something like this, so you have an x and a y value, and then let me relabel this. Let's label this x1 and y1, and then x2 and y2. That means whenever you get those points, you're going to take your y values and subtract your x values and subtract, and then divide your answer. I'm going to show you an example of how to do this. So here, I give you 2 points. So the points are 2, 4, and 5, 8. These are points on a line. You don't really even have to know what the line looks like right now. Just know the 2 points. We don't know if it's going to be positive or negative yet. Are we moving up? Are we moving down? We'll find out. So if we look here, let's label 2, 4 as my x1 and y1 values. So the first number is your x, the second number is your y. So this is how far right you move on the graph. This is how far up you move on the graph before you plot a point. Then we'll label 5, 8 as my x2 and y2 values. So this is another point. This is how far right you would move. This is how far up you would move. Our rise over run equation specifically states that you need to subtract your y values. So rise, let's do that first. So we'll subtract our y values. So my y2 is 8 and my y1 is 4. And 8 minus 4 is 4. So this is our rise. Then we need to subtract our x values. So x2 is 5, x1 is 2. And 5 minus 2 is 3. That's our run, so how far left and right you move. The formula states that you do rise divided by run. So in this case, your slope would be 4 divided by 3. You can leave your slope like that. There's no reason for you to write it in a decimal form or simplify it. 4/3 is perfectly fine. If you prefer, you could say that this is 1.3 repeating as well. So I just have it written out like this: 8 minus 4 divided by 5 minus 2 equals 4/3. So to sum up, what that really means is to go from point to point to point, or whole numbers, I should say. You're moving up 4 each time and over 3 each time. Here's another example. This one gives us -3, -6, and 2, 9. So if we label these as our x1, y1, and x2, y2, I'm just going to go in order. It's up to you how you label them. So this one is x1, y1, and then this one I'll call x2, y2. So if we follow our rise over run formula, that means we have to subtract our y values. So my y values are 9, subtract -6. Well, 2 negatives right there, so 9 subtract a negative. That's the same thing as like 9 plus 6. So remember, 2 negatives squished together like this kind of morph into a plus sign, which means that our rise, 9 plus 6, is going to be 15. Our run, those are our x values, are 2 and -3. So 2 subtract -3. Again, we've got two negatives kind of squished together here, so it morphs into a positive. So that makes our run 5. So rise divided by run is the same thing as 15 divided by 5, which is 3. So in other words, this just means that you are rising 3 and running 1 each time. So going up 3 over 1, up 3 over 1, up 3 over 1. So that is a positive slope here. All right, last example with 2 points. This one is actually going to give you an undefined slope, and I'll show you how. And if we label these again, I'm going to go through this one a smidge faster. X1 and Y1. Hold on. X2 and Y2. When we do our formula, if we subtract our Y values are 12 and 9, and that will get you 3. Our X values are 6 and 6. If you subtract those, you get 0. When you do this formula, if you put that in any type of calculator, it should give you something like this. It'll probably just say UNDEF, which stands for undefined. That means you can't actually say that there is a slope, because what that is doing is giving you a straight up and down line. So on a graph, it'll just be completely vertical like this. And there's no way that it can have a slope, because slope has to represent how far you're moving left and right as well. So this is an undefined slope. It's kind of a weird example, but just know dividing by 0 is bad. It tries to blow up the world. So if you get a divide by 0 like this, you would call it undefined. Now let's look at some where you're given a graph and you actually have to find your 2 points to put into the formula. So this right here has a bunch of points on it. I recommend looking for ones that give you whole numbers. So this box spot up here, this box spot down here, and even this spot in the middle right here would be great to use for your 2 points. So any of those points are usable. This spot right here is great, this spot, and this spot, but you have to know how to read a graph again. So remember, it's your x value first, then your y value. So my x value for that middle point, this one here, if we look at it, x is -4. And my y value, well, it's not going up or down, it's right smack dab on the x-axis, so my y value is 0. If I'm looking at this point over here, this x value is -3. So if you go down to the x-axis, my x value is -3, and my y value is 5. This point down here, this x value is -5, and the y value is also -5. Those 3 points are very usable. If you try to use any other points between, you're kind of guessing. Like, I don't really know what point this would be right here. It looks kind of like -3.4, and then your y value is 3, but it's too much guessing and you don't want to deal with that. So look for whole numbers, like these 3 here. I'm going to use the highest point and my -4 0 point in order to create my actual formula for rise over run. So remember, your y values are subtracted. So this number right here, I'm going to label as my y1. Let's label this x1 and y1. And then I'm going to use these points as my x2 and y2 values. You don't have to use 3 points, just use 2 points. So let's go ahead and put that into our formula. So our y's are our y values, so subtract those. Our y values are 5 and 0, which give us 5. Our x values are -3 and -4. So -3 minus -4, remember 2 negatives kind of squished together like that is really adding. -3 plus 4 is 1. So if we divide these, rise divided by run, we get 5 divided by 1, which simplifies to just 5. So the slope of this graph is 5. What that really just means is that we're going up 5 over 1. So we're going up 5 and over 1 to get to our next point. You can even look at this point to this point. We went up 5, 1, 2, 3, 4, 5, and then we went over 1. So that's kind of a quick and dirty way in order to solve this. Just figure out how did you get from one point to the next. We moved up 5 over 1, so that's the slope. All right. This one here, I'm going to just show you the quick and dirty method for this one instead of the actual formula. So if we try and find 2 points on this graph, that'll help us out. So I'm going to use my little circle tool here again. This is a good point to use. This is another whole number point we could use. So I'm going to circle all the ones that you could use to get from one location to the next without dealing with decimals. Any of those could be used in your formula, but I'm just going to use kind of this rise over run idea. How did we get from one point to the next? So in this method, so read it from left to right. Remember, always go left to right whenever you're reading a graph. So this is my leftmost point. So my rise, I'm actually going down 1, and my run is over 2. We're going down 1, over 2, down 1, over 2. So this is a pattern. We're constantly moving down 1 and then over 2 again. So if I wrote this actual formula out, well, my rise is down 1, which makes it -1. And then my run is over 2, which means I'm dividing by 2 each time. So this is actually the slope of the graph. Down 1 over 2, my slope is -1/2. If you actually wanted to use the formula, you would need to use 2 of these points, just like we did on the previous graph. All right, I'm going to jump to the next graph and the final one that we're going to look at. This one here is an example of an undefined graph. We talked about this earlier with just 2 points, which means there's a divide by 0 somewhere in here. And that's not okay. The world tries to explode when you divide by 0. So this does not have slope. This one here, it's going straight up and down, so there's no run. There's no left or right that we can move, which means the slope is undefined. So just know if you see a straight up and down graph, that is called undefined in my book. And lastly, this is just kind of a general conclusion here, showing you all the types of graphs you could run into. So remember, read a graph from left to right. So if I read this from left to right, I'm moving upwards, which means I should have a positive slope. If I read this from left to right, we're moving down, which means we have a negative slope. This one, the final one I'm looking at over here, that was the example we just looked at, undefined, because only the Flash can really climb a building like that. No one else can, so you can't have a slope like that. This one has a slope of 0. So if it's just straight across, completely horizontal, it has a slope of 0, because think of it like you're jogging across the road, the sidewalk, whatever, and if it's flat, well, it has no slope. There's no hills anywhere in here. This one is down a hill, this one is up a hill, this one is, there is no hill, which is 0. So that's all I have for you today. Sorry for the longer video, but I wanted to give you all possible examples that you would need. Make sure you take any notes. You're welcome to write down these pictures and use them as necessary. Good luck.